In this video, we're going to do section 3.3, the conditional and circuits. Okay, so in very quick terms, the conditional means your if-then statements. The if part is called the antecedent, and the then part is called the consequent. Let me write that down. Oh my gosh. So typically we use the letters P and Q. So if P, then Q. The P is called the antecedent. Oh no. Nailed it. And the Q is the consequent. Bink. We talked about if-thens earlier on in the class, but they come back to say hello. And with these if-thens, they will now join our and, or, and not, and will create a truth table for them, as you can see off to the right of the screen. That's what we'll be filling in pretty soon. Just because a sentence doesn't say the actual words if and then doesn't mean it can't be turned into an if-then. And we have some examples. So all dogs are animals. Think about it. Pause the video if you need to. Think about how you can restate this same exact sentence, but as an if-then. Pause the video if you have to. Okay. So you could say, instead of all dogs are animals, is if it is a dog, then it is an animal. My dog is quite hungry right now, and he wants to eat. That's what you're hearing back there. Marsh, it's okay. It's okay, buddy. Lay down. Lay down. You just ate. He did. He ate like 2 hours ago. He's like part cat. Okay. So by me saying if it is a dog, then it is an animal, that is the same thing as all dogs are animals, where the antecedent, oh, I cannot draw a box, is it is a dog, and the consequent is it is an animal. So we could write if P, then Q. Next one, I'll buy the tablet when the price drops. So try to do the same thing. Pause the video, think about this sentence in an if-then way. Okay, hopefully you said if, what has to come first for me to buy the tablet? The price has to drop. So if the price drops, then what will happen? I will buy the tablet. So our P here is the price drops, and our Q is I will buy the tablet. Excellent. Okay. Okay, so now let's fill in these tables off to the right. Now, to be very clear, this first table might hurt a little bit. So if you just want to say, I need to just know what the truth values are in the lower right table, you can skip to that time and figure out what that is. But this first part's sort of important because it explains why the truth table is the way it is. So let's suppose we were outside and we saw something on the ground. Don't worry, it's moving, it's fine. And we said, is it a dog? And let's suppose that the answer was, yes, it is a dog. So then can we conclude that we know it's a dog? Can we conclude that it is also an animal? Yeah, because all dogs are animals. It's a possibility. We could say yes. So what's the validity of this? True. That's a valid argument. Is it a dog? Yes, it's a dog. Is it an animal? Yes, it's an animal. True. But what if it was a dog? Would it be valid to conclude that it's not an animal? So we know that thing's a dog. Can we say for sure it's definitely it's not an animal? No, we can't. So the validity would be false. We'll talk about the implications of this in a second. What if the thing on the ground was definitely not a dog? And that's our last two cases. Well, if we definitely know it's not a dog, notice it can or cannot be an animal. We don't know anything past it's not a dog. So with that said, if the if part is false, we use benefit of benefit of the doubt here to say, in this case, it may or may not be an animal. Just because it's not a dog doesn't mean it's not also an animal. So the validity is true because it may or may not be an animal in this case. So this is the truth table layout for if P then Q. True, false, true, true. So the big one is something true cannot imply, that's what this arrow means, something false. Oh, I hate when that happens. Oh, I skipped so far. Something true cannot imply something false. And then the reason for the last two here is if the antecedent is false, it may or may not be the consequent. So we just give the benefit of the doubt, which says, all right, true, we don't know. So that's why the last two are true. So the bottom right, that is your truth table for if P then Q. I'm going to skip to the next slide here. No. Okay. So with that, I want you to make a truth table. So I just realized that the video I told you to watch last week is not correct. Sorry if I gave you any headaches. Please watch video number 36 because 36 has the if then. I am so sorry. Nobody emailed me, so I'm guessing it was fine. So please watch video number 36 and then come on back and we'll do more if then stuff. Okay, so in that last video, number 36, I think I talked about how important noticing that some of the columns were the same. And with that, that does mean that we made some congruent or equal statements, we could say. One of those, it deals with P and not Q. What we're going to do is we're going to make the truth table for P and not Q. How many rows do we need? Hopefully you said 4 because it's on the screen. But more importantly, we only have 2 letters, P, Q. And so 2 squared is 4. So we need 4 rows. As far as the columns, again, it depends on the problem. This one, 4 is great. So we'll need a P column. We'll need a Q column. To finish out this statement, we'll need a not Q column. And then notice here's our P, here's our Q. So we'll need a P and not Q because that says and. Okay. Remember, start off with half true, half false for P, and then cut that in half. So in this case, alternate true, false, true, false. To get the not Q column, we'll negate the Q column. So if T was true, if Q was true, then not Q is false. And if Q was false, not Q is true. Hopefully you have printed out by now the little chart that I put together for you in Blackboard and have that next to you, please. All right. And then now we'll do P and not Q. Well, again, here's the P column, here's the not Q column, and we'll AND them together. Remember, AND is only true if they are both true. So we have true and false is false. True and true is true. False and false is false. False and true is false. Notice the pattern. False, true, false, false. That is the complete opposite of true, false, true, true. In other words, if you negate an if-then statement, then it is the same thing as an AND statement. In this case, P and not Q. So let's suppose, yeah, this is good. Let's make up a if-then statement. I'll just write it here. P would be it rains. Q will be I wear my boots. So if it rains, then I will wear my boots. Don't worry about semantics and verbs. It's fine. Okay, so let's suppose I said to you, if it rains, then I will wear my boots. And you know I was lying. So what would be the correct phrase or sentence to say? We will follow this pattern. P and not Q. P, it rains, and this statement here, not Q. If Q is I wear my boots, then what's not Q? I don't wear my boots. So together, it rains and I don't wear my boots. So if you need to negate an if-then statement, it becomes an AND statement. What if you wanted to rewrite an if-then without using AND? Well, let's, at the bottom there, consider not P or Q. We're going to make another truth table. P and Q are two unique letters, so we need 4 rows. What else do we need to complete this? We need a not P column, and then we'll have our Q for here, and we'll have our not P for here. So that's enough. We'll just OR them together. As before, 4 rows, true, true, false, false for P, true, false for Q. To make not P, we will negate the P column. So false, false, true, true. Great. And now we will OR these 2 columns together. Order doesn't matter for OR and AND. Peanut butter and jelly is the same thing as jelly and peanut butter. Cream or sugar is the same thing as sugar or cream. So the order in which the columns appear, don't worry about it for AND or OR. For if then, PQ being switched makes a huge difference. In fact, that's the entire next section. So be careful with that. So what I'm saying is here, instead of saying false or true, I could say true or false. It's the same exact thing. So I'm just going to go left to right here. So true or false is true. False or false is false. True or true. True. False or true. True. Notice this time we have the exact same layout as if then. So what we just showed was if P then Q is the same thing as not P or Q. So going back to our rains example, if it rains, then I will wear my boots is the exact same thing as it does not rain or I will wear my boots. Means the exact same thing. So in your next 2 videos, you'll have one video where you learn to negate an if-then. That's this formula, if you want to call it that. And in the next video is where you learn to rewrite a sentence without using if-then. That's that formula there. So the stuff we have on the top right, very important, but it will be provided for you on the test. In fact, it's already on that sheet that I gave with all the stuff for it. So if you would, watch videos 37 and 38, and then come on back. All right, in the last part of this section, we talk about circuits. If you are going into electrical engineering or programming, this is for you. If you're not going into those things, this is for you. Congratulations. We'll talk about the big box off to the side. You know what? Let's do that now, and we'll do the circuits first later. So the big box off to the side summarizes some very common statements that we could see to simplify truth tables even, or as we're about to do, circuits. For instance, if I said P or P, that's just the same thing as saying P. Q or P and P is the same thing as saying P. Remember down here, for an or statement, if one of them is true, then the whole statement is true. So P or something definitely true is true. Whereas for an and statement, if part of it is false, then the whole thing is false. P, no matter what P is, and false, the whole thing is false. And that's basically what all these are saying, is that there's a way to simplify things, which will come down to our example down below here. So I'm gonna bounce around. In this idea of a circuit, the whole idea is that you have electricity and you are running it through some wires, and depending on the layout of the wires in terms of how they're connected, so to speak, the question will be, can the electricity go from the left to the right generally? And more importantly, is it in the most ideal setup? And by that I mean is, let's talk about coding, programming. I could write a program that's 1,000 lines and it works just fine. Someone else could write the same program in 20 lines. And what will happen is it'll work better because it takes the computer less time to process it. So when we talk about circuits and simplifying circuits, the whole idea is, can we do the same thing but better? That's the whole idea here. Sometimes we can simplify a circuit, and sometimes we can't do anything. It is what it is. Before we're getting too down, we're already really down the rabbit hole. Let's talk about what the two types of circuits are. You can have two types of gates, is really the word G-A-T-E, gates. You can have an AND gate, and in an AND gate, this would be where like the electricity starts, and what will happen is the electricity is here, boop, 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 bink. And in order for the electricity to get here, I'm just going to write goal. It has to go through the first gate and the second gate. So when you have a circuit where one follows directly after another, that's an AND gate. So P and Q. We're going to use the notation that we have established so far in this chapter. If you go into circuit building, logic gates, blah, 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 you're going to see some other notation. I think this is an and then I think this is an or. You could read about it if you want to. It might even be in the book. But we're just going to use the V and upside down V. So again, in order to go for the electricity to start on the left and get to the goal on the right, it has to pass through P and also pass through Q. So When you have one following the other, that's an and. Now let's talk about or. Same deal. Here's where the electricity is starting. I cannot draw one of the newer bulbs, so you're getting the old style. And this is where we want the electricity to end. But what could happen is the electricity could go through P, or it could go through Q. So if you've ever heard of parallel circuits before, that's what this means. So the electricity could go here, as long as the P gate is closed, to get to the goal, or it could go through Q to get to the goal. So this is an example of what P or Q would look like. So one more time, and one follows the other, or parallel. Okay, now here's where it gets fun. You can have ands within ands, ors within ors, ands and ors within ands and ors, blah, 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 blah. So these two graphs can be combined, and what we'll do is we'll do the next example here. I'll show you what it means to actually simplify, and then we will draw the circuits for the beginning and for the end, so you can see how the circuit was simplified. Okay, before we simplify it, I just realized there's an error in my work. I know. We're going to change this guy to and. Sorry about that. Okay. Now let's talk about simplifying this circuit. So what's going to happen is our main operation here in not P implies the quantity not P and Q. The main operation is the if-then. So let's turn that into, get it out of the if-then statement. And remember, to do that, P implies Q is the same thing as not P or Q. That's what we just had earlier. Okay. So again, what this says here is you negate the antecedent and you or the consequent. That's what that says in English. Don't get stuck on the letters P and Q. All right. So to turn this into an or statement, we negate the antecedent. The antecedent is not P. The negation of not P is P. And we or the consequent. What's the consequent? Not P and Q. All right. So I'm just going to put a dot here for visual. We're going to turn that thing into a circuit and using the drawings that we have up above. All right. Now looking at our dotted line here and looking at our chart that we have, there's one of these that we can use to rewrite our dotted line. Look at the very first one there. Notice it starts with something. In this case, it happens to be a P or. And what's happening is this P or is being quote-unquote distributed to the Q and then to the R. So P or Q, P or R, and this is the symbol that goes in between. So that's the format we have. That's how this chart is used. You're looking for the format. You're putting things in places. I'm going to erase my stuff up here so it's easier to read. Boop, boop, boop. So we're going to quote-unquote distribute this P or through. So we will have the same thing as P or not P, and becomes the main connector there, P or Q. Excellent. All right, great. Look back at the chart. P or not P. What is P or not P? P or not P is always true. So I replaced P or not P with true. We have an AND statement here. Now think about it. In order for an AND statement to be true, what must be true? Both parts must be true. Well, we know the first part is true. That's what that says. So in other words, for this electricity to pass through the circuit, what also must be true is the second part, P or Q. Thus, the simplification of P or Q, the simplification of true and P or Q is just P or Q. So in order for this original circuit to work, not P implies the quantity not P and Q. All that matters is P or Q. I'm going to put like an open square there, just so we can designate it. Okay, now for funsies, I'm going to draw what the circuit would have looked like if we didn't simplify it. So the main operation is an OR, and OR, remember, says you split. So I'm starting off my OR. In the top one, we have the left part of the OR, which is just a P gate. Hooray! In the bottom part, we have to make not P and Q. Well, this is an AND. So within the OR is an AND statement, which means we need to have one follow the other. We can make a gate for not P, and then right after it, we make a gate for Q. So this is what the circuit would look like for not P implies the quantity not P and Q, which is the equivalent to P or the quantity not P and Q. Your choice. So that circuit, very, very fun, exciting. I know that's what you're saying. But what we just discovered was it is the same thing as P or Q, and that's what we have up here actually. We actually already did the circuit for P or Q. So the one in purple there is the simplified version of the lower one in the dark blue down here. And that's how you simplify circuits. You rewrite it using these statements that we have in the box there. And then in your homework you might also have to draw the original and possibly draw the end result. Just so you can say, oh, I made it easier. Okay, that finishes 3.3. Did I say that? Yeah, I said that. Hooray. Okay. Have a great day. I keep forgetting to tell you what to do next. All right. Please watch video number 39. I said that right. Okay. Now you can go. Bye-bye.